See, in the previous class, we have done all the properties of modulus and conjugate. So, Dhruvi, can you please explain me this question once? Dhruvi? Hello, Dhruvi?
Yes, sir.
Can you please explain this question once? Z1 minus 2Z2 upon 2 minus Z1 Z2 bar is unimodular. No idea? Hello? Anyways, let's try one or two more questions before going further. Question is, if Z minus 1 upon Z plus 1 is purely imaginary, then prove that magnitude of Z is 1. So, now what they are saying, Z minus 1 upon Z plus 1 is purely imaginary. So, if a complex number is purely imaginary, that means that complex number plus its conjugate is 1. Like if Z equals to say x plus iota y, Z conjugate will be x minus iota y. Got it? So if Z is purely imaginary, so let us assume Z is only x. So Z conjugate is minus, Z is only iota y, so Z conjugate is minus iota y. So Z plus Z bar goes 0. So that means Z minus 1 upon Z plus 1, Z bar minus 1 upon Z bar plus 1, this is going 0. Understood? Now I'll take LCM. LCM is Z plus 1, Z bar plus 1 is Z minus 1, Z bar plus 1 plus Z plus 1, Z bar minus 1. This value is 0. Now the denominator goes to 0. What do you get? ZZ bar minus Z bar plus Z minus 1 plus ZZ bar minus Z plus Z bar minus 1 equals to 0. Now if you realize this plus Z minus Z cancel, this minus Z bar plus Z bar cancel. So what do you get? Twice of ZZ bar minus 2 equals to 0. That means ZZ bar is 1. That means magnitude of Z square is 1. So that means magnitude of Z is 1. Am I clear? Is that clear to everybody? Now, have a look. Very good question. This is a complex number which is purely imaginary. And if a complex number is purely imaginary, that means that complex number and its conjugate will be complex number plus its conjugate will be 0. Understood? Now, let's do a new question. Question is, if argument of Z is pi by 4 and magnitude of Z plus 3 minus iota mod is 4, then find Z. See, Argument of z is pi by 4. So this is for sure. See, let z is x plus iota y. Then argument of z is going to be tan inverse y upon x. Argument of z is going to be tan inverse y upon x. Understood? Now, they are saying tan inverse of y by x is pi by 4, means y upon x is 1. So y equals to x. But especially while we are talking about argument, it won't be the entire line y equals to x. Whereas what it will be line y equals to x, which is lying in the positive direction of x-axis, excluding 0, because 0 is the complex number which is only defined by its magnitude but not by argument. Now, this is what? Magnitude of z minus 3 plus iota is 4. So this is what? Means distance between z and a complex number minus of minus 3. Minus 3 plus iota is 4. So this is a complex number whose distance from a point minus 3 comma 1 is always 4. So where it is minus 3, minus 1, minus 2, minus 3 comma 1. Got it? Now, and radius is what? Radius is 4, so somewhere like this. So this is the only complex number that will be satisfying it. And definitely this distance is going to be 1. So while this is 1, this will also be 1. So this distance is going to be under root 2. Got it? So this will be magnitude of z minus 3 plus iota is 4. Now see, the kind of neat and clean diagram I have made, it is quite clear that this point is going to be 1 plus iota. Otherwise, you may solve a line y equal to x and the circle x plus 3 whole square plus y minus 1 whole square equals to 4. And now you can see this point 1 plus iota is also satisfying both the equations. Understood? Very good question. Have a look. Now we'll do a very, very important question. Show that all the roots of the equation z to the power n cos theta naught, z to the power n minus 1 cos theta 1, z cos theta n minus 1 plus cos theta n equals to 2. Show that all the roots of this equation where theta 1, theta naught, theta 1 and so on, theta n belongs to R, lies outside the circle magnitude of z equals to 1 by 2. Give it a try. Show that all the roots of this equation where θ1, θ2 and so on, θn belongs to R, lies outside the circle. Yes, anybody? JNV Shimoga, would you like to explain something? Nasik? Now see, they are saying, show that all the roots of this equation will lie outside the circle. Now see, we have done a property that magnitude of Z1 plus Z2 plus Z3 less than or equals to mod Z1 plus mod Z2 plus mod Z3. Now I will apply the same thing here. Z to the power n cos theta naught, n minus 1 cos theta 1, cos theta 2 and so on, z cos theta n minus 1 plus cos theta n mod. It is less than or equal to magnitude of the individual ones. Magnitude of z to the power n cos theta naught, magnitude of z to the power n minus 1 cos theta 1, and so on, magnitude of cos theta n. Now, if in all of them, this cos theta is at their maximum 1. So this will further be less than magnitude of z to the power n plus magnitude of z to the power n minus 1, and so on, magnitude of z plus 1. Left side is 2. Given to me is 2. Now see, if mod z is more than or equal to 1, inequality is satisfied. Got it? First thing done. Now, if mod z is less than 1, then this right side, I can write it 1 plus mod z square and so on up to infinite. I can take this series up to infinite. So 2 is less than equals to 1 upon 1 minus mod z. That means 1 minus mod z is less than or equals to 1 by 2. That means mod z more than or equal to 1 by 2. Understood? So mod z, okay, this cannot be equal to because of we are taking the series to infinite. So mod z is more than 1 by 2. So ultimately, what did I get? I got mod z more than 1 by 2. Yes or no? Mod z more than 1 upon 2. So that means what? Every complex number lying outside the circle mod z equals to half will always satisfy this. Understood? Now, have a look. A good question it is, and tough also, I would say. Now, question very popular. How to get the square root of a complex number. So the question is, find, say I'll take a simple question, 3 minus 4 iota. Find under root of 3 minus 4 iota. Now, understand how do we resolve this root. See, let this under root of 3 minus 4 iota is x plus iota y. Then square both sides. X square minus y square plus 2 iota xy. Understood? Now, x square minus y square is 3 and 2xy is minus 4. Am I clear? Now we can write x square plus y square whole square. So it is 9 plus 16, that is 25. So x square plus y square is equals to 5. See, I am not taking plus minus 5 because x square minus y square has to be positive. Then x square minus y square is, we have considered it 3. Now if I solve it, you get x square as 4, means x as plus minus 2. You get y square as 1. So y as plus minus 1. Now one more thing to notice, this x into y is negative. So if x is positive, y is negative. If y is positive, then x is negative. That means this under root of 3 minus 4 iota is satisfied by two complex numbers, that is 2 minus iota and minus 2 plus iota. Understood? Have a look. Very good question. Got it? In certain books, you will also find a formula for this, but I do not recommend remembering any new formula, which is very less used, also not so important, also tough also. And method to find the under root is also very easy. So I insist not to remember any formula for this. Directly go for it. Got it? Now, concept of rotation. See, first of all, let me explain it to you. Say there is a complex number Z1, then there is a complex number Z2, and angle between them is theta. Got it? Let us assume this angle is alpha and this angle is beta. So Z1 we can write as magnitude of Z1 e to the power iota alpha, and Z2 I can write as magnitude of Z2 e to the power iota beta. If I divide both of them, Z1 by Z2 is mod Z1 upon mod Z2 e to the power iota alpha minus beta. And also it is very much clear to me that beta minus alpha is theta. That means Z1 upon mod Z1 into e to the power iota theta is Z2 upon mod Z2. Understood? Z1 upon mod Z1 into e to the power iota theta is Z2 upon mod Z2. So one thing, how did I get it? Let us consider this is some unit vector. So vector upon its magnitude is unit vector along Z1. multiply it by e to the power iota theta. So if you are rotating and taking Z1 to Z2 anti-clockwise, so we will multiply this Z1 as into e to the power iota theta. And finally, what do you get? Unit vector along Z2. So Z1 is rotated to get the unit vector along Z2. Understood? Now, another form of this is, say these are two complex numbers. This is Z1, Z2, and Z3. Now, line joining Z1 and Z3 is rotated by an angle theta anti-clockwise, and we got line joining Z2, Z3, line segment joining Z2, Z3. So, what is that? We have rotated Z1 minus Z3 upon magnitude of Z1 minus Z3 converted into unit vector e to the power iota theta, because you rotated it by an angle of theta. And what did you get? Z2 minus Z3 upon magnitude of Z2 minus Z3. Understood? So the vector which we are rotating, we will multiply it by e to the power iota theta. And in the right side, we will write whatever we have achieved. Am I clear? Now see, there is a third form. Now third form is, let us say Z1, Z2, and after rotating it by an angle of theta, you get Z3, Z4. So how will I'm going to use the rotation theorem. Z1 minus Z2 upon magnitude of Z1 minus Z2 into e to the power iota theta. And finally, what did you get? Z3 minus Z4 upon magnitude of Z3 minus Z4. Understood? This is how we use rotation theorem. Am I clear? Got it? Now, let's do a question. Let a square ABCD is given such that Z1, Z2, Z3, and Z4 and Z4 represents vertex A, B, C, and D respectively. Now express Z3 and Z4 in terms of Z1 and Z2. Yes, give it a try. Quickly. Now see, there's a square A, B, C, D. This is Z1, Z2, Z3, and Z4. Now they are saying express Z3, Z4 in terms of Z1 and Z2. Now, see, can I say if line joining Z2 and Z4 anti-clockwise by an angle of pi by 4, you get line joining Z1 and Z2. But yes, if this side is A, this is going to be A root. So it will be Z4 minus Z2 upon its magnitude A root 2. It has been rotated by an angle of pi by 4. And what did I get? Z1 minus Z2 upon magnitude of Z1 minus Z2 A. Now this A and A cancelled. Got it? So you get Z4 minus Z2 upon root 2 into cos pi by 4 plus iota sin pi by 4 Z1 minus Z2. Am I correct? So it will be Z4 minus Z2 is Z1 minus Z2 upon 1 plus iota 2 goes upside. Just to like make it normal, you can multiply by 1 minus iota. So that is 2 times 1 minus iota Z1 minus Z2 upon 2. 2 cancel. So this is Z4 minus Z2. So your Z4 is going to be what? Z2 plus 1 minus iota Z1 minus Z2. Got it? There is a possibility that somebody else use rotation theorem, someone else get answer bit of different, which will be ultimately same, but it may look different only. Have a look quickly. Now, another question. If Z1, Z2, Z3 are the vertices of an equilateral triangle, Z1, Z2, and Z3 are the vertices of an equilateral triangle, then prove that Z1 square plus Z2 square plus Z3 square is Z1 Z2 plus Z2 Z3 plus Z3 Z1. Z1, Z2, and Z3 are the vertices of an equilateral triangle, then prove this. Now see, this is an easy question. What simply we have to do? Use the rotation theorem twice. Got it? How? See, this is a triangle. Say this is Z1, Z2, Z3. So one rotation theorem I will use here. How? Z1 minus Z3 upon, say its magnitude is A, since they are equilateral triangle, all will be same. E to the power iota rotation by pi by 3. What do you get? Z2 minus Z3 upon A. One equation. Understood? Now use another rotation like this here. So Z3 minus Z2 upon A, e to the power iota pi by 3. And what do I get? Z1 minus Z2 upon A. Now divide first and second. A will cancel. E to the power iota pi by 3 will cancel. You will get Z1 minus Z3 upon Z2 minus Z3 minus Z2 is Z2 minus Z3 upon Z1 minus Z2. Now, still little bit of simplification and a cross multiplication, you will get Z1 square plus Z2 square plus Z3 square is Z1 Z2 plus Z2 Z3 plus Z3 Z1. Fine. Okay. Have a look. Well, now, say this is something very important to be taken note. Given a complex number Z, then what is iota Z? This iota Z is like Z e to the power iota pi by 2. So that is what? Another complex number obtained when line joining Z and origin by 90-degree anti-clockwise. By 90-degree anti-clockwise. There's a very popular question on it. Question is, if area of triangle made by Z, iota Z and Z plus iota Z, say, is 50 square units, then find mod Z. This is the question. Give it a try. Simple and easy question. Quickly try. Now see. In the Argand plane, let us assume this is Z. So if you rotate it by 90 degree, then this is what? This is iota Z. Now if I complete this quadrilateral, then what is going to be this? This is going to be Z plus iota Z. Yes or no? They have provided you this area. This is the area they are providing. Now it is very much clear. This is going to be a square. And if it is a square, so this area is equal to this area. That is O. So if I call them A and B, then area of triangle OAB is going to be what? 50 square units. Now, if this is mod Z, this is also mod Z. That means half of mod Z square is 50. So magnitude of Z square is going to be 100. So magnitude of Z is going to be 10. So this is what you have been asked for. And this is your reply. Understood? Easy question. Now, let's understand about the cube root of unity. Cube root of unity means roots of the equation z cube equals to 1 or z equals to 1 to the power 1 by 3. Roots of this equation either real or imaginary, whatever they are. So z cube equals to 1. Now if I go algebraically, I will get z cube minus 1 equals to 0. That is z minus 1 into z square plus z plus 1 equal to 0. Now one root is z equals to 1, another is z square plus z plus 1 0. So z is what? Minus 1 plus minus under root 3 iota upon 2. Understood? So I got three roots. Z cube equals to 1 equation K. I got three roots. One root is 1. One root is minus 1 plus under root 3 iota upon 2. And another root is minus 1 minus under root 3 iota upon 2. Now, this root is definitely 1. This root is going to be omega. So this is going to be omega square. So roots are what? 1, omega and omega square. Am I clear? So this is one way to get the cube roots of unity. There's another way to get the cube roots of unity using De Moivre's theorem. And from that theorem, we also understand the nth roots of unity. But as of now, we don't have sufficient time to go for it. This is a fabulous chapter having a very good weightage in JEE Mains in advance. So make sure you do not skip it and do it thoroughly. All right. That will be all from my side today. So before leaving the class, I would like to ask for a small feedback. So please. All right. I think that column is not visible to me. Anyways, thank you so much. Take care, students.